and I will be going through a simple smart contract here. And so smart contracts in Solidity can be written in mainly two languages. One is Solidity and another is Serpent. And mainly the Solidity is more like JavaScript, while Serpent is more like Python. And here we will go through code of Solidity. So this is a very basic smart contract, very simple smart contract. And the first line here is this refers to the compiler version for which this code is smart contract code is written, and like here it is 0.4.0. So the caret there it signifies that the versions from 0.4.0 up to versions till 0.5.0 excluding 0.5.0 is valid, so that this is to ensure that if there are some changes in the compiler, so that after deployment the code doesn't behave abruptly. So coming to the next line, there is a contract keyword, and this keyword is in Solidity. The contract keyword just signifies a type of a class, just like in C++. Contract, you can call it a contract class, and the name of this class is simple storage, and it's just like a class where all the variables are defined and then the functions are defined which change the state of the variables. So the state of this contract is like the variables which are declared. So here is a simple contract, only a single variable, that's stored data variable is written here. So this simply signifies that the state of this smart contract is the value of the stored data variable. So you can see there are two functions here. One is a setter function and another is a getter function. So setter function here is a write type of function. There are mainly two types of function. One is the write function and another one is the read function. The write function, what write function does is it simply updates the state of the smart contract. Here we can see that the value of the stored data changes to the value of x. So the state of the smart contract changes here, and these type of write transactions have to be added into the blockchain, and these type of transactions get mined. So, and another type of transaction here is simple read transaction, that is a get transaction. Here what this transaction does is simply returns the state of the smart contract, it's the value of the stored data. It doesn't affect update the state of the smart contract. So here it's simple that this transaction will not get mined. It's not even a transaction, it's just a call to the contract. So moving here, we can see that let's talk about constructor in the later slide, like this slide. So here the compiler version is defined. Right now the current compiler version latest is 0.4.25, and but it's a slightly older code. So here the coin contract class is defined, where there are some variables defined, and then there is an event. And then some functions are defined corresponding to those variables. So here, like first of all, we can see that there are two variables, minter and balances here. So the first variable, the address keyword there is so the address keyword there is simply signifies that this variable will be of type Ethereum account address, so that it's of like 160 bits, so that an Ethereum account can be stored in this type of variables. So the next keyword is mapping. This mapping signifies the type of a hash map. We all know that it's a key value pair thing. And so the balances variable here simply stores the amount of coins that an Ethereum account address possesses. So this is to maintain the balances of all the coin holders. So here we can see that the variable is public. So what the public variable here does is that it makes these variables visible to the outside world. So what happens is that when we make a variable public, then a getter function is automatically added to the code, so that now anyone from outside can simply call the minter, although it's a variable, but they can call a minter function, and that will simply return the value of the minter variable. So that's how the public comes in play. So if public keyword is not defined, then the variable will be internal to the contract, and it won't be accessible outside this smart contract. So the next line here is the event sent. So this event keyword is to utilize the logging facilities of Ethereum platform. So what this does is simply emits an event with the name sent, and here it will log out the value of address from which the tokens were transferred, address of the receiver, and finally the amount is the number of tokens, coins that were transferred from one address to another. So these events are fired when a transaction is finally mined and is added to the ledger. So the JavaScript UI can simply listen for these events, and through this dApps are developed. And next line here in the code is the constructor. You can see that the name of the content class in this function is same. So this is the constructor of this class. So if this constructor is not defined, then the state will be set to null, so that the minter and the balances, everything will be set to null. So if here we are defining a constructor. So at the time of deployment, when the bytecode of this this content will be compiled by the compiler, then the bytecode of this compiler, this code will be stored on the blockchain. And when that happens at the time of deployment, the constructor function is also executed by the EVM, and the minter variable is set to the message.sender. Here this message.sender is a bit tricky. The message variable is a magic global variable in Ethereum Solidity. It simply it simply is a way to interact with the blockchain. So message.sender signifies the person who is calling. This signifies the account address, which is who is calling this function. So a message.value signifies the amount of ethers that were sent to the smart contract. Message.data signifies the call data of the transaction. So the different variables can be there. So this here we are saying that message.sender. So what happens in this constructor is that the minter variable is set to the address of the first account address that deployed this smart contract. So here this is what it all does. So when the contract is deployed, in the beginning the state of the contract will be that the minter address will be the address of the contract address that deployed the smart contract, while the balances mapping will be null. So for all the addresses, the value of the value of the token coins will be null. So that's how the contract is initialized when the contract is deployed. And we can see here that we can see next two functions, function main and send, and there is a modifier there, the public modifier. So there are mainly four types of modifier of a function in Ethereum Solidity. One is public, another one is external, internal, and private. So what public keyword does is that this simply means that this function is visible to all the functions inside this contract, and all the functions outside any other contract can interact with this function. So that is the public keyword. And the next is internal. If it is defined as internal, then this function will only be visible to the functions inside this contract or the contracts that are derived from this contract. Inheritance is also there, considered as like a class, and so it's visible to the derived contracts as well as this contract. So and next keyword is external. If this is external, then this function will not be visible to any of the internal function. It will be only visible outside to other contracts. That's done to save amount of gas. We will not go in there, but that's external. And finally there is private. Private keyword simply means that this, even in the inherited classes, this variable will not be visible. This function will not be visible. So that's what this modifier does here. And the next in the main function, the first line is the require that message.sender is equal to minter. So this function can simply mint any amount of coins out of thin air. We can see that it simply takes the receiver address and the amount, and whoever the message.sender, it allocates the receiver that amount of tokens. So if anyone can call this function, simply call this function, then that would be a problem, because then anyone would be able to increase their balance as per they like. So that would be a problem. So the solution is that in the first line there is a check that the message.sender, like the person who is calling this contract, is the account of only of the minter. So that was initiated when the constructor was called. So this function can only be called by the minter address. No one else can call this. So if anyone else will call, the transaction will fail and the whole state will be reverted. If the minter, the owner of the contract calls this, then the balance of the receiver will be updated. So, and the next function is the send function. It simply does is that we can, if suppose I have 100 coin in my account, then I want to transfer 50 coins to Love, then I can simply transfer 50 coins from my account to Love's account, and then but I must not be able to transfer more than 100 tokens. So the first check there is that I must not be able to transfer more than 100 tokens. So, and after that the balances mapping corresponding to message.sender me is updated. My balance is deducted by 50 and my new balance is 50, while the Love's balance is updated by 50 and his balance x plus 50 gets x plus 50. So in final line, what this does is that it emits the event that is defined above. So this logs this event, and any front-end UI listening for this event can catch it using Web3.js and simply develop dApps on this. But it is important to note here that this event will only be emitted if the transaction is final and is mined. If suppose there was some issue in the third line here, then the whole this event will not be emitted. The whole state will be reverted back to its original state, and that's how, because the transactions have to be atomic in Ethereum. Otherwise, there could be problem that my balance was deducted, but his was not updated. So this transaction has to be atomic. So if there is a problem, then either the whole transaction will get added or the whole state will be reverted. That's for the security. And I think that's all from me. And next, Love will walk you through a simple token.